everyone. So in this chapter, 5.2, we will discuss the definite integral. So here's the amazing definite integral in all of its glory. So the basic definition is that if f is a continuous function defined for the integral from a to b, we divide the interval into n subintervals of equal width. If x of 0 equals a and x of n equals b, and a sample point is chosen in each subinterval, we shall call x sub I, where I equals 0, 1, 2, 3, or etc. Then the definite integral of f from a to b is the integral from a to b f of x dx equals the limit as n approaches affinity of the summation n when I equals 1 of f of x sub I dx, or delta x. So here's the definite integral compared to the Riemann sum. When we find the area under a curve by adding rectangles, the answer is called a Riemann sum. The width of a rectangle is called a subinterval delta x. The entire interval a to b is called the partition. Consider the partition on the left below. So as we can see, the area is divided up into rectangles, and that's what we call the Riemann sum. However, there's area that's either left out or added to the total sum. So therefore, the Riemann sum is an approximate estimate, or an estimation of the area. So it's the summation of n when I equals 1 of f of x sub I times delta x, whereas the definite integral is the actual area, so it's the definite area of the function f of x, and it's defined by the interval from a to b of f of x dx. So here's some important information about integrals. The symbol shown below is called an integral sign. In notation, the integral from a to b f of x dx, f of x is called the integrand, a and b are called the limits of integration. A is the lower limit and b is the upper limit. Dx has no official meaning other than to denote the variable of integration. The procedure of calculating the integral is called integration, and the area above the x-axis is positive while the area captured below the x-axis is negative. The summation of f of x sub I times delta x is the approximate net area, and the integral from a to b of f of x dx is the total net area. So here are some rules and notes for sigma notation and summation equations. So when you have a summation of I, this equals n plus 1 over 2, or you can simplify it. When it's I squared, it equals n plus 1 times 2n plus 1 over 6. And when it's I cubed, it's n plus 1 times 2 squared. So when you have a constant after the summation, you can simply add the constant m times. And then there are other rules listed below. When you're adding summations, you simply, of a sub I plus b sub I, you can simply add them together and subtract them as well. So here's an example of evaluating a Riemann sum. So this example in A will evaluate the Riemann sum for f of x equals x cubed minus 6x by taking sample points to be right-hand endpoints with a equals 0, b equals 3, and n equals 6. So we have the equation for the Riemann sum, and basically what we're going to do is plug in the endpoints and then find the area below each of those, and we'll get negative 3.9375 for that area, and then we'll evaluate the integral from 0 to 3 of the same equation. And in doing so, we get negative 6 to the 3/4. So here are the properties of the definite integral. So when we have the integral from a to b of f of x dx, this is basically backwards. We make it equal to the negative integral from b to a f of x dx. And when we have an integral from a to a of f of x dx, that simply equals 0 because there's no area between the same point. And when we have an integral with a constant, we simply take the constant outside of before the integral. And then when we have the integral from a to b of two functions added or subtracted, we simply add or subtract the functions. So here's the property of integrals. If f of x is greater than or equal to 0 for a is less than or equal to x, which is less than or equal to b, then the integral from a to b of f of x dx is greater than or equal to 0. And if f of x is greater than or equal to g of x for a is less than or equal to x, which is less than or equal to b, then the integral from a to b of f of x dx is greater than or equal to the integral of a to b to g of x dx. If m is less than or equal to f of x, which is less than or equal to m for a is less than or equal to x, which is less than or equal to b, then n times b minus a is less than or equal to the integral from a to b of f of x dx, which is less than or equal to mb minus a. Thanks for watching.